Okay, let's dive into this. Right now, there is absolutely no bigger buzzword in tech than AI agents. I mean, if you look online, you're just hit with this massive, overwhelming wave of hype. You see them portrayed as this cure-all, right? A magical black box that's going to run your entire business while you sleep. And people are using the term to describe everything from, a basic coding assistant that helps you write a quick Python script, all the way up to these massive, seemingly autonomous workflow automation tools that honestly sound like science fiction. It can start to sound a bit vague or even like literal magic. But in this explainer today, we're going to completely strip away the buzzwords. We're going to break down exactly how these systems are built from scratch using nothing but simple code and clear logic.
So, to get started, we really have to ask the fundamental question here. What exactly is an AI agent? It is incredibly tempting to think of an agent as this mysterious, highly intelligent black box, like a ghost in the machine that just somehow knows how to do things, how to browse the web, and how to solve your problems. But that couldn't be further from the truth. Actually, by the end of this, you're going to see that the core idea is surprisingly simple, and it's entirely programmable. It's logic, guys, not magic.
At its absolute core, an AI agent is simply a program with a loop. That's literally it. It is not some massive, incomprehensible framework that requires a PhD to understand. It's an iterative loop. It reads an input from us, decides what to do next, takes an action, and then observes the result of that action. Then, it just repeats the process, over and over. And once you can visualize this basic programmatic loop running in the background, well, everything else we're about to discuss is going to start making perfect sense.
Section 1. Anatomy of an agent. So, the crucial point is, to really grasp how this loop functions, we have to understand the fundamental difference between a standard large language model, or LLM, and an AI agent. An LLM by itself, it's mostly just text in, text out. You type a prompt, it guesses the next best words, and replies instantly. But an AI agent takes that input and runs it through a continuous loop where it has access to tools. This is a real game changer because it actually holds back its final answer until it decides its task is truly complete. It doesn't just guess the next word, it actively works a problem until it's solved.
Let's map these technical components to some real-world analogies so we can see how they all fit together. First up, we have the brain, which is the LLM. This is what gives our agent its natural language intelligence and reasoning capabilities. Next, we have the hands. These are the tools and functions that give our agent the agency to actually affect the outside world. Then there's the personality, which is defined by the system prompt, telling the agent exactly how to behave. And finally, the transcript. This one is absolutely crucial because it acts as the agent's memory and context. Without the transcript, the agent would literally forget everything you just said. With it, it can maintain long, complex interactions without missing a single beat.
Moving on to Section 2, giving the agent hands.
So, the brain alone isn't enough to interact with the world, right? Let's ask a logical question here. How does a text-based model, whose knowledge is completely frozen in its past training data, know the live, up-to-the-minute weather in London? Or say we're building an AI games master for a tabletop RPG. How does it physically roll a 20-sided die to get a random number? Well, the secret is it doesn't. The LLM doesn't just magically fetch live data out of the ether. Instead, when we ask for the weather, the agent uses its brain to realize it needs outside help. It then outputs a structured code request formatted exactly like a programmatic string. It generates something precisely like get_weather with the location argument set to London. So it's not giving you the weather, it's explicitly asking for a specific tool to be used. Here's another example to really drive this home. In our RPG game, the LLM outputs a structured request to roll_dice with 20 sides. The critical thing to remember here is that the LLM is not actually generating a random number itself. No way. Your local application, the actual code wrapping around the LLM, catches that specific request, runs the Python script to roll the virtual dice, and then prepares to hand that result back to the LLM.
Let's view this whole thing as a dynamic conversation between you, the brain, and the application. Step 1, the user requests data. Step 2, the LLM thinks about it and outputs that structured tool request we just talked about. Step 3, your application steps in and actually runs the tool. And finally, step 4, your application feeds the observation, like say the number 17 from the dice, or 25 degrees Celsius for the weather, straight back to the LLM. Only then does the agent use its brain to formulate a natural language answer to give back to you.
Section 3. Teaching the agent to think.
Okay, so once an agent has hands to use tools, we can start upgrading its brain with advanced reasoning patterns. The simplest reasoning pattern out there is called reflection. Imagine asking an agent to write some Python code. It generates a first draft. But then we program a second step where the agent takes on the persona of a master coder, think someone like Andrei Karpathy, to ruthlessly critique its own work. It finds its own errors, suggests clever improvements, and then automatically generates a much better version too. It's essentially talking to itself to improve. Pretty cool, right?
But the ultimate planning loop, the real secret sauce behind almost every major agent framework out there right now, is a design pattern known as REACT. That stands for Reason and Act. It's a specific programmatic loop that forces the agent to combine internal step-by-step thinking with external tool execution. This completely elevates the system from a simple text generator to a highly active problem solver.
So the REACT loop works in 4 very strict steps. First, the agent must output a thought, explaining its underlying logic. Next, it outputs an action, which is our tool call. Then it waits for an observation from the application. And it just loops through thought, action, and observation, over and over and over, until it is completely satisfied that it has enough information to finally output a final response.
Let's watch this agent think in motion with a complex math problem. Say we ask the agent to sum some large numbers, multiply the result by 5, and find the logarithm. The agent starts, thought, I need to sum these numbers. Then, action, sum_2_elements. Once the application feeds the sum back, the agent loops again. Thought, now I need to multiply. Action, multiply_elements. You see? It methodically works through the problem, tool by tool, step by step, until the math is perfectly solved.
Which brings us to Section 4. Building multi-agent teams.
We've seen what a single agent can do, but to reach the true pinnacle of this technology, we have to scale up. We have to ask ourselves, what happens when a workflow is just too massive or too complex for a single agent's brain? I mean, if you give one agent 50 different tools and a massive system prompt asking it to be a master coder, a meticulous project manager, and an obsessive quality tester all at once, it's going to get confused. Imagine a frazzled human employee running around trying to do 5 specialized jobs at once. They are inevitably going to drop the ball. The solution? Dividing the work into smaller subtasks handled by specialized agents. Let's look at how this breaks down in a team workflow. Say we have a clear goal. Write a poem, translate it, and save it to a local file. Instead of one frazzled agent trying to do it all, we bring in 3 distinct experts. The poet agent writes the English poem. Then it hands its work directly over to the translator agent, who takes that English text and turns it into Spanish. Finally, the translator hands its output seamlessly to the file writer agent, who uses a specific tool to securely save the text file. It's clean, sequential, and highly effective teamwork.
Now, in computer science, this specific structure is called a directed acyclic graph, or DAG. I know, that sounds like heavy jargon, but it really just means a one-way workflow map where a team of agents logically pass their context down the line. If you've ever used complex workflow orchestrators like Airflow in the corporate world, it's the exact same philosophy, just populated by intelligent AI agents instead of standard rigid Python scripts. And this brilliantly illustrates why separating roles is so absolutely crucial. A single overloaded agent with a massive prompt loses focus, hallucinates answers, and inevitably uses the wrong tools. But a multi-agent crew with specialized roles and clean handoffs, that operates exactly like a well-oiled factory assembly line. Think of a car factory where one precise machine expertly attaches the doors while the next one smoothly paints the frame.
Each agent is small, laser-focused, and incredibly reliable at its specific job. Finally, Section 5. Real-world agent applications. We've covered a massive amount of ground today, from basic loops all the way up to entire multi-agent crews. But I want to highlight this core quote from our sources. An LLM alone is mostly text in and text out, while an agent is the loop around the LLM that can decide when to use tools. Just think about that for a second. The magic isn't the model, the magic is the loop. The true power and the incredible utility lies entirely in that simple programmable loop that you can build around it.
Once you truly understand that an agent is just a loop with tools, well, the possibilities are virtually endless. You can connect it to your personal calendar, your massive corporate document drives, or your entire software code base. So I'm going to leave you with this provocative thought. How could you apply a simple reasoning loop to automate your own daily workflow? Start small, build the loop, give it a tool, and just watch what happens. Thanks for joining me on this explainer, and I'll catch you in the next one.